Okay, we're going to go over Gay-Lussac's law. You should have filled in your notes from the notes page. Remember that this is a direct relationship between pressure and temperature. Gay-Lussac's law has that direct relationship between pressure and temperature the same way that Charles's law has the direct relationship between volume and temperature. Again, the temperature must be in Kelvin, so you must remember to change your temperatures to Kelvin by adding 273. So let's look at the practice problem 4.8. And we have a gas. It has a pressure of 6.58 kilopascals at 539 Kelvin. So we've got our first pressure, P1, and our first temperature, T1, nicely given to us in Kelvin, so we won't have to add 273. What will be the pressure? So we're looking for P2 at 211 Kelvin. So we've got our T2. Again, it's given to us in Kelvin, so we don't need to add 273. And the volume does not change. So our givens, we've got P1, 6.58 kilopascals. T1 is 539 Kelvin. P2 is what we're looking for, and T2 is 211 Kelvin. So we're going to write our equation. It's going to be Gay-Lussac's law. P1 over T1 is equal to P2 over T2. And we're going to hold P2 where it is, and we're going to move T2. And so that means we're multiplying both sides by T2. So just to remind you, P1 over T1, P2 over T2. We're multiplying both sides by T2. Remember, whatever we do to one side, we must do to the other. Because we have T2 in the numerator and the denominator, it cancels out on this side. And so we end up with P2. And remember, I'm just flipping it because I like to have my unknown that I'm solving for on the left. My P2 is equal to P1 times T2 over T1. And it doesn't matter whether I write it as T2 times P1 over T1 or P1 times T2 over T1. Either way is fine. Then we just plug in our givens. P1, 6.58 kilopascals. T2, 211 Kelvin. And our T1, 539 Kelvin. So Kelvin cancels out, and we're left with units of kilopascals. Remember, we multiply across the top, divide by what's on the bottom, and we're going to look at the number of significant figures. And again, we have 3 in each one. So our answer must have 3 significant figures. So we have 6.58 times 211 divided by 539. And so we're going to be cutting off after the 7, since the 7 looks to the 5 to see whether it rounds up, and indeed 5 and above causes that number to round up. So we have 2.58 kilopascals. Alright, let's do practice problem 4.9. The pressure in an automobile tire is 198 kilopascals. There's our first pressure. At 27 degrees C. There's our first temperature in degrees C, so we have to add our 273 to it. At the end of a trip on a hot sunny day, the pressure has risen to 225 kilopascals. There's our P2. What is the temperature of the air in the tire? And assume that the volume hasn't changed. So we are looking for T2. We're going to list our givens. P1, 198 kilopascals. T1 is 27 degrees C plus 273, and that's going to be what, 300 Kelvin. P2 is 225 kilopascals, and T2 is what we're looking for. The equation we're going to use is Gay-Lussac's law. P1 over T1 is equal to P2 over T2. Alright, now we are looking for a variable that is in the denominator, and that's always a little more challenging. So let's look at how we can rearrange this. So I'm going to do it the messy way first, and then I'm going to show you a little bit neater way. So we've got our P1 P1 divided by T1 is equal to P2 divided by T2. And I have to solve for T2. The first thing that I have to do is get T2 out of the denominator. If I do not remove T2 from the denominator and say move P2 over to the other side, I will have 1 over T2, which means I'll be solving for the inverse of T2, which is not what I want to do. So my first move is going to get T2 out of the denominator. To do that, I have to multiply both sides by T2. Remember, I said this was going to get messy at first. T2 is now out of the denominator. However, it is not isolated. So we're going to now have to come over here and move P1 and T1 to the other side. So that means we're going to have to divide by P1 and multiply by T1 to move them. So P1, dividing both sides by P1. P1 cancels on this side. Now multiplying both sides by T1. Remember, whatever you do to one side, you have to do to the other. Okay, we've removed P1 and T1 from this side and moved them to the other side. Now, the cleaned up version, T2 is equal to P2 times T1 divided by P1. P2 times T1 divided by, well, that's okay, I still have lead. P1's on the bottom. Now, a little bit neater way to do this. If P1 over T1 is equal to P2 over T2. Remember, when you move from one side of the equal sign to the other, you have to move the position of your variable. So T2, when it moves to the other side, it's going to go up since it was down. P1 is going to move down because it was up. T1 is going to move up because it was down. A little bit neater. Same result. T2 is equal to P1 times T1 divided by P1. So now let's plug in our givens. So P2 is 225 kilopascals, kPa. T1 is 300 Kelvin, and P1 is 198 kPa. So our pressure units cancel. We're left with units of Kelvin, which is the temperature. Very nice way to check yourself. 225 times 300, multiplying across the top and dividing by 198. And now this is a little tricky. This actually has 3 significant figures because it's addition, and we're looking at the point of uncertainty. That would be at the ones position. And so, actually, yeah, we'll go with that. So this has a decimal here. So it has 3 significant figures, so do the other 2. So when we look at our answer, it has to have 3 significant figures as well. So we are going to be dropping everything after the decimal, but we are going to be putting the decimal there. Oops, and that is not a 0. Because it's dropping a 9, it rounds up to 1. So we don't have to put our decimal there to show that the 0 counts. It's actually a 1. Alright, so there are more Gay-Lussac problems, problem videos from the homework, so check them out.